have we discussed the functionality of the VAV and, why it's important and that kind of, just from the mechanical side?
Robert covered a little bit about that on Tuesday, but I can kind of cover in a little more detail than I think what he covered. So historically for mechanical systems, there was two ways that air handlers met space conditions, and that was by a constant volume system. And now that in the past, I don't know, probably 30 years or so, the variable air volume systems have come into play. They weren't as popular early on just simply because you had to have some means of controlling airflow, which generally end up being pretty wasteful on the energy side. But with the advent of variable speed drives and the cost dropping significantly on them, we've gone to the variable speed drives to control airflow. And when you meet your energy needs or your space needs with a variable airflow rather than a constant airflow with changing temperature, use that variable airflow with a constant temperature, you're able to save a lot of the fan energy. And if you think about it, your typical system has hot water, chilled water circulating around the building, and then you have airflow around the building to meet the needs. And if you're able to pump water, well, it's a lot less expensive, a lot less energy intensive than moving air. Just think about it. Physically, it's easier to move a bucket of water than it is to try to capture same volume of air and move it around. It just takes more effort. So air is very expensive to move, and it saves us energy if we are able to vary the amount of air and use temperature as a way of meeting the space needs. That's the basic behind a variable air volume box. It does that varying of the airflow to a space to meet the heating and or cooling needs of the space, as well as ventilation. But the VAV is really there for a purpose of space conditions.
Ted, can I add a couple of things? I think some people are going to laugh at me for saying what I'm about to say, but about the VAV box itself. I guess it doesn't have to be this way, but traditionally the VAV box is a one-way device. The air is supplied through the circular input and proceeds through the box and is connected to the rest of the system on the rectangular output. The reason I say that, and I know it sounds very obvious, is that this thing behind me, if you look behind me at that's one of the walls in our VAV, I'm sorry, in our DDC training room. It's almost all ALC equipment on that back wall, but there is a VAV box on that back wall that was made up by the DDC people. It wasn't a box that was, purchased with all the bits and pieces. It's, I don't know, 2.5-inch diameter kind of thing, and it was put together. And in that case, they induced the flow through the box. They put the fan on what would traditionally be the output of the box. And strangely enough, I have actually seen a couple of cases where VAV boxes have been connected backwards, where an attempt has been made to supply the air through the rectangular connection and direct it to the rest of the system and the zone through the round connection. So I just wanted to mention that to people because, I think most of us that have been in the air conditioning business are a little surprised that we have to say that, but apparently there is some confusion among a few out in the business about how a box is connected. The only other thing I'll mention is that there can be a fair amount of error in all these control sequences if that sensor is not very well understood and calibrated. It's actually a couple of lessons that was teaching the testing, adjusting, and balancing for Peter, and we dedicated a couple of weeks just to how to deal with that sensor and to calibrate it. Okay. So I just wanted to mention to you, I'll find a picture of that box before the end of this institute and show it to you. It's kind of a surprise that people would try to induce flow through that box, but there are some misunderstandings out there, and I just wanted to mention that.
Yeah, I think that pressure sensor calibration issue can be very important. And just with our brief discussion on Tuesday about it, you look at the configuration of the box, and you have restrictions in the box that create flow factors. And so that's impacting what you do. And you also have to make adjustments for pressure and things like that. So there's just a lot that you need to consider when doing it. So that would be a good lab to have.
Ted, are you going, is Robert going to talk about the sequence of operations this morning, or are you going to talk about that a little bit? What makes sequencing the VAV box more challenging in particular?
Well, I think Robert was going to take that end of it.
Okay.
At why that's more challenging. He's been kind of touching on that the past couple of days already. So, Robert, you want to sum that up and add to it if you can?
Absolutely. So, as Ted and Hadley have pointed out, VAV boxes are an exceptionally important and useful portion of our commercial building control systems from the climate side. But they need some real attention, both from their initial installation and later on. They actually need maintenance. I know it's not anything that we commonly maintain. There's not a huge amount to maintaining them, but that airflow calibration issue that Hadley mentioned is exceptionally important. And if you run into a building, when I was working in controls, you can have an amazing controls programmer, and you can have an amazing mechanical engineer, and they can set up a building just to be, from a sequential standpoint, just working, like a tuned Ferrari. But if the airflow calibrations aren't done properly, if the water flow calibrations aren't done properly, that tuned Ferrari can operate like, your mom's 1970s Honda Civic. It really is one of those things that is amazingly, oh, there you go, a Pinto, there you go.
California utility system. I'm just kidding.
Challenging to overcome. So that calibration point is exceptionally important. Traditionally, we've done the manufacturer of a given control system frequently dictates whether you're going to do a single point calibration or a 2-point calibration. Single point calibrations are typically done at the VAV is driven to a maximum airflow set point as designated by the design engineer, and a flow hood is used to actually measure the amount of air coming through. And then that number is fed back into the control system to develop a calibration factor at that maximum airflow set point. A 2-point calibration does it at the maximum airflow and at the minimum airflow. And because of the nature of these VAV boxes, the associated calibration factors can actually be quite different because of those airflows. And part of that is because of the nature of the flow damper, because everybody who hasn't worked with a VAV box sees it from a conceptual standpoint, thinks that with your damper fully closed, you have 0 airflow. That makes sense. With your damper fully open, you're going to have as much airflow as you can get out of that box at a given duct static pressure. And we kind of assume, because we're used to it in the real world, that if we're at 45% or 45 degrees, 50% open, we're getting 50% airflow. And that is vastly inaccurate. Because the damper, as soon as it opens, when you exceed about 20% open position or 25% open position, that's normally the point when you're getting almost half of the airflow out of the box. So those last, 45 degrees or that last half open really doesn't usually change your airflow as much as we would expect. It absolutely does change the airflow, but just not as much as we would think. So that is something to keep in mind as you are working with VAV boxes.